Well, so apologize for the slight delay. Luckily, this is something which still works and instead of Teams. And welcome to the sixth wheel lecture of Applied Mathematics, the first lecture about case study 4. As you can see, this case study is about bacterial growth. So last couple of weeks you were working on a chemistry case study. This week we're going to use a biology case study. And it's all about bacterial growth, as you can see. And there is one formula in particular which describes bacterial growth. And in the first 10 sheets, we will slowly build towards that formula. And afterwards, I'll tell you something about the logarithm, like I said I would a couple of weeks ago. And then there are a couple of things I want to show in Excel. I think we did most of them already. And on Blackboard you will be able to see a couple of videos which you can use to start with exercise 1 to 3 of the fourth case study. Alright, so the first term I want to introduce is the generation time. So if you have a bacteria of an amount of bacteria, bacteria can grow, bacteria can reproduce, and if you want to put numbers to it, then you can use the term generation time. And the generation time is basically the time required for the amount of bacteria to double. So if, for instance, you've got g hours of generation time, then at time 0 you have, for instance, 1 bacteria. After g hours you have 2 bacteria. After another g hours you have 4 bacteria. And after another g hours you have 8 bacteria. You keep multiplying the amount of bacteria by 2. And because it's easier to use numbers instead of symbols, this is an example if your generation time is 1 hour, which means that it takes about an hour for the amount of bacteria to double. And that means that after 1 hour there are 2 bacteria, after 2 hours there are 4 bacteria, and after 3 hours there are 8 bacteria. And let's see a question about the exam. So the exam is about both the case studies and ALEX. There will be a couple of mathematical questions, which you had in ALEX as well. Questions about logarithms, questions about fractions, and all that sort of stuff. And there will be questions about the case studies as well. And one good example of a question of the case study is from case study 3, I guess. One of the questions had a red box around it. And that's a kind of question you can expect on the exam. Oh well. Back to the sheets. So this is about the generation time, and then you can also introduce a symbol n, and n is the amount of bacteria, the number of bacteria. And well, as we can see, after at time 0 you have 1 bacteria. After 1 hour you have 1 times 2 bacteria. After 2 hours you have 1 times 2 times 2 equals 4 bacteria, and you can do that every time. And you can also see a pattern. You can see a pattern that after 1 hour you have 1 times a 2. After 2 hours you multiply the amount of bacteria 2 times by 2. And after 3 hours you multiply it 3 times by 2. So after 5 hours you multiply 1 by 2 times 2 times 2 times 2 times 2. So you would have 1 times 2 raised to the 5th power, which is 32. And if you don't know the amount of hours the bacteria were grown, you can use a symbol. So you can use t hours, and that means that after t hours you have n, the amount of bacteria is 1 times 2 raised to the tth power, which basically is 1 times 2 times 2 times 2 times 2, and then there will be t times a 2. So what if you don't start with 1 bacteria? What if you start with, for instance, 3 bacteria? Then basically still the same. After 1 hour the amount of bacteria double, so you go to 6 bacteria, and after another hour you go to 12 bacteria, and after another hour you go to 24 bacteria. And you can see if you go to the formula over here, you can see you start out with n of 3, then you've got n equals 3 times 2 raised to the 1st power, n equals 3 times 2 raised to the 2nd power, and it goes on and on and on. So you can use a general formula, which is this formula, where n, the amount of bacteria after t hours, equals to n0, the amount of bacteria in the beginning, times 2 raised to the power of t, where T is the amount of time, the amount of hours the bacteria are reproducing. And you can use this formula to get more complex values, to calculate more complex questions about the amount of bacteria after several hours. And so, for instance, if you've got 9 bacteria at time 0 and you let them grow for about 5 hours and the generation time is still an hour, you get n equals to n0 times 2 raised to the power of t, so 9 times 2 raised to the 5th power. That means you have 288 bacteria after 5 hours. Well, there's one more thing about the formula we're going to use, and then that is what happens when you have a different generation time. And I'm not going to give a derivative of this formula, but basically your formula will become n equals to n0 times 2 raised to the power t over g, where t is the time the bacteria are growing and g is the generation time in hours. So as you might notice, because our g was 1 in the last couple of examples, if you divide by 1 you only have t, so I was kind of just hiding the g there for a moment. But if you use this, if your generation time is like a half an hour, that means that your amount of bacteria double every half an hour, so your bacteria are growing faster. And if you have t is, so after 0 hours you have 1 bacteria, after half an hour you have 2 bacteria, and after 1 hour you have 4 bacteria. You can just use the formula and calculate the amount of bacteria. Well, so you can, it's funny to relate this to corona, but it's harder to relate this to corona because in corona your viruses are reproducing in the body at a different rate, and the spreading of corona is more related to how much of the virus particles you get into your system before you're getting sick. It would be fun to do it like that, but it would make it way too complex for today. Well, just to finalize this, another question with generation time of 2 hours, so it takes a lot of more time for the bacteria to double. So after 2 hours you would have 2 bacteria, and after 4 hours you have 4 bacteria. And again, just fill in the formula and you eventually are able to calculate the amount of bacteria after any specific amount of hours. If you receive 3 parts of corona in your body, you can probably calculate the spread in your body, but it's a lot of more biology than than I know of. Because I'm a chemical engineer, I know something about biology, but not a lot. Well, if there are no further questions, then I'll start with some stuff about case study 4 in Excel. So you have a formula you want to basically make a model of in Excel. We want to do some calculation in Excel. And in this case, there are 2 things you know. You know the generation time of your bacteria, and you know the amount of bacteria you're starting with. And you can make a table just like you did for the other case studies by just making a nice table in Excel. And on Blackboard there is a video you can use to see how it works. How you can prepare for the exam? Well, basically, if you have to make sure you finished Alex before your exam, because then you probably be prepared because you finished all those. You finished all the topics, at least most of the topics. And if you did all the case studies, if you are able to answer all the questions, you should be able to do the questions of the exam as well. The questions will be different of course, but they won't be more difficult. It's just similar to what you did during the case study, but then the question might be slightly different, or we might do something you did in case study 3, we might let you do it for something in case study 2, or the other way around. But if you work on the case studies, if you made the case studies yourself, if you just study the case studies again, if you make sure you are able to do all the questions, then you should be fine. First question, you have to create a table with n as a function of t, and you want to make a column of ln n, and ln is the natural logarithm. And for the first part, just make a table and use dollar signs. I think you know where you have to use dollar signs for. You use it if you refer to a cell, you want to keep referring to the same cell after you copy the formula. Then use the formula will keep referring to the same cell you logged using the dollar signs. Man, it looks like we got some trolls. Welcome, trolls. I hope you enjoy your time. So back to this, you can use dollar sign formula. I'm quite sure I explained that before. And if you can use the small box in the bottom to copy the cell to other stuff. Anyway, back to this one. So you have the natural logarithm, and if you want to use the natural logarithm, you can use the ln function, which is the equality sign ln, and then the cell you want to calculate the natural logarithm of. And if you don't know what the natural logarithm is, so natural logarithm is basically the in order to understand that, you want to make sure to understand what a logarithm is. And the logarithm is basically the inverse function to exponentiation. So if you've got the 10 log of logarithm to the base 10 of 1,000, which is 3, that's because 10 raised to the third power equals to 1,000. And another example, if you got the logarithm to the base 2 of 32, which is 5, that's because 2 raised to the 5th power is 32. And you can have a general equation. Your general equation is logarithm to the base b of a equals to c. That means that a equals to b raised to the power c. And what's natural logarithm? The natural logarithm is basically the logarithm to the base e, and then you have e is Euler's number, which is like pi. It's just an irrational number, which is 2.718282, etc. It has an infinite amount of decimals. You don't really have to know the exact number, but in Excel you can just use the equality sign exp1 with a parenthesis, and then you've got e raised to the power 1, which is basically your e. So for now you can hand in case study 1 to 3 if you have it already, but I saw most of you already did. You can start making the questions of case study 4, and you can use videos on Blackboard to answer questions 1 to 3. And yeah, we will use so DJ, we will switch to Teams afterwards, but we can switch back to Teams now. I'll shut down the stream. Hopefully it's clear until now, but I'll answer your questions in Teams as well.